Now that we're getting close to the exam, I'll try to combine all information about alkenes in one mind map. So let's do this together.
The very first thing you need to understand about alkenes is the type of bonds. Alkenes contain the pi bond. Now, pi bonds are weaker than sigma. In addition, pi bonds restricts rotation. The restriction of rotation results in the formation of geometric isomers like cis and trans isomers in alkenes. The type of overlapping with these pi bonds are sideways overlapping, and the position of that pi bond is above and below the sigma bond. We're now going to look at the reactions of alkenes. I'll start with hydration. The hydration of alkenes requires nickel catalyst and a temperature of 150 degrees Celsius. The addition of hydrogen to alkenes forms alkane. The second reaction is the oxidation. The oxidation of alkenes requires acidified potassium manganate. During these reactions, the color changes from purple to colorless, and it will form dialcohols in this case. The addition of steam or the hydration of alkenes forms alcohols, and this reaction requires phosphoric acid catalyst and 300 degrees Celsius. Halogenation occurs at room temperature and pressure. That is when we add halogens such as bromine, and this results in the formation of halogenoalkanes. The last reaction in this series is the addition of bromine water. Now, this reaction is required to test for saturation for the presence of the pi bond. Reaction occurs again at room temperature and pressure. The color change during this reaction is from orange to colorless, and the product is bromoalcohol. Now, the type of reactions or the mechanism of reactions of alkenes is electrophilic addition. During these reactions, the type of bond breaking that takes place is heterolytic bond breaking. During electrophilic addition, you have to realize that there are two types of products that you can get. It really depends on the type of alkene that you have. So while adding hydrogen bromide, it depends if your alkene is symmetric, that is, if both carbons around the double bond have identical groups, or if it's asymmetric. That is the case when the groups around the double bonds are different. With electrophilic addition to a symmetric alkene, you will always end up with a single product. The addition of hydrogen bromide to asymmetric alkenes gives you two types of product. There's the major product and the minor product. Now, in the major product, the hydrogen from hydrogen bromide is added to the carbon that is rich with hydrogen. And in the minor product, you will add the bromine to the primary carbon. Like in my case here, that's a minor product. The bromine is added on the flank or to the carbon on the left-hand side, which is a primary carbon. But the major product, which is the one that's more likely to form, is when the halogen or bromine in my case is added to a secondary carbon in the middle.